All right, so we're continuing on with the student activity sheet number 2. We didn't get to 12, 13, and 14 in class today, so I did want to spend a little bit of time on that. We will touch base with it on Monday, but for those of you that are wanting to complete the worksheet this weekend, I thought this would be helpful. Number 12, it says observe the graph of t equals 10 plus 0.07 m, and its inverse, m equals 100 over 7t minus 1,000 over 7. Both of those are graphed below, and it wants us to compare those two graphs, identify the x and the y intercepts on both. Well, the two graphs are both linear functions. They're both lines. The graph is a line. The x-intercept, there is no x-intercept on this graph, on the graph on the left. X-intercept means where does it cross the x-axis? Well, here's the x-axis, and that line never crosses the x-axis. So there's not an x-intercept, but there is a y-intercept. The y-intercept is right there at 0, 10. That's a y-intercept. And then the reverse is true on the graph on the right. There is no y-intercept, but there is, in fact, an x-intercept. Here's your x-intercept. It is the inverse of that point, and there is no y-intercept. Now, number 13 says, how does the graph of the inverse compare to the graph of the original relationship in which the cost depends on the number of minutes taught? How does that graph compare one to the other? They're both lines, and the x and the y intercepts are reversed. So your x becomes your y becomes your x in your intercepts. What geometric feature do you notice about those two graphs? Use the animation on page 8, it says, to help you see this feature. Well, if you notice, the line is symmetric about the y equals x line equation. So if we draw that line, the graph, if we graph the line y equals x, which is just 1, 1, 2, 2, 3, 3, 4, 4, and so forth, then the line is symmetric about that equation. So if I reflected, I could reflect the blue line across this orange line, and it would mirror, one mirrors the other. It's a mirror image of the other. So it is a reflection, or it's symmetric about the line y equals x. And then number 15, we got to in fourth period, but we did not get to number 15 in first period. Number 15 says, rewrite the function rule here by solving for m in terms of t. So we're given t equals 10 plus 0.07 m, and we're asked to solve for m this time. So in order to solve for m, I'm going to subtract 10 from both sides. And then I'm continuing to try to solve for m. So I'm going to divide both sides by 0.07. And this is where several of you got hung up. So we have m equals t minus 10 divided by 0.07. I don't like having this decimal down here in a fraction. It's not exactly a proper way to leave a fraction. So in order to get rid of this decimal, I want to move that decimal 2 places to the right, which is essentially multiplying it by 100. And remember from our previous video, I can multiply anything by 100 over 100 because that's just like multiplying by 1. So then I end up with 100t multiplying here, 100t minus 1,000 over 7. And then one more step, m equals 100 over 7t minus, that's supposed to be 1,000, 1,000 over 7. And again, we have our slope of 100 over 7. I think I did that in. We have our slope of 100 over 7, and we have our y-intercept of negative 1,000 over 7. And so m equals 100 over 7t minus 1,000 over 7 is the inverse function to the original function that we started out with here. T equals 10 plus 0.07m. One we solved for t, here we solve for m, so one is the inverse of the other. Again, I hope this was helpful. If there's anything you'd like for me to screen record for you that you didn't quite get in class, I'd be happy to do that. Just shoot me an email this weekend, and I would be more than happy to try to help you out. Hope you have a good weekend.